Hello students, my name is John Frederick and I am a certified Cisco instructor. I work for CED Solutions and I'm going to show you Discovery Lab number 19 and we're going to see how to configure BGP, Border Gateway Protocol, route reflectors. So in this discovery, we're going to eliminate the need for a full mesh between IBGP neighbors, which are BGP neighbors that are in the same autonomous system. And we're going to do that by taking our autonomous system, which is the one here in the center, BGP Autonomous System 1, and we're going to take router 3 and make it a route reflector. So notice to the left we have BGP Autonomous System 100 for ISP1, and on the bottom right we've got BGP Autonomous System 300 for ISP3B, and again our area here that we are controlling is BGP Autonomous System 1, again making router 3 a route reflector. This lab should take about 20 minutes to complete. And let's go ahead and get started. Now the IP addresses and IGP, which is OSPF area 0 in the middle there, are already pre-configured for us. So we are going to look at an eBGP session between ISP1 and router 1, another eBGP session between ISP3B and router 4, and an IBGP session between routers 1 and 3, and another IBGP session between routers 3 and 4. So note that no IBGP session is between router 1 and router 4 routers. The OSPF protocol has also been pre-configured as the Interior Gateway Protocol, the IGP, to ensure that all the internal links and loopbacks and the next hops are accessible in our autonomous system, which again is Autonomous System 1. So again, on router 1, we're going to verify which BGP sessions are established. So let me bring up router 1. And we're going to go ahead and type the command show Bgp Summary to see that information. So notice we do have our BGP router identifier, which in this case is 10001. Our local autonomous system number is, again, autonomous system number 1. And notice that down at the bottom of this output, we do see that we have two neighbors. So 10.0.0.17 and 172.16.11.11. And then we've got all the statistics. We are talking about BGP version 4. These are the autonomous system numbers, how many messages we received, how many we sent, what is the table version, your input queue, your output queue, how long the session has been up or down, in this case up, and then the prefixes that we've learned from those neighboring routers, which are the networks and subnets. So again, we should see that only the BGP sessions that are established, so we have our eBGP session to the ISP1 router, and that's the neighbor that has the 172.16.11.11. And then we have an IBGP session going over to router 3, and the neighbor for that is 10.0.0.17. So now we want to look at router 3 to verify which BGP sessions are established there. So let's go ahead and bring that up. And we're going to do the same command, show BGP Summary. And again, we see the router 3's BGP router identifier. Again, there's the 10.0.0.17. Again, we're in the same autonomous system, so local autonomous system number 1 here. We see all the statistics, and again, we have the two neighbors down at the bottom. So in this case, we see that only BGP sessions are established. We have an IBGP session of router 1, and that's the 10.0.0.1. And then we have another IBGP session going down to router 4, which is the neighbor IP 10.0.0.49. So a similar output, and again we can see on the far right that we are learning prefixes along with all the other statistics. So let's go and check out router 4, which is our last router in our autonomous system. And again, we're going to do show Bgp summary. So once again, we see router 4's identifier, 10.0.0.49, the local autonomous system 1 here. And if we look at the statistics, we have two neighbors, 10.0.0.17, which again is the session to router 3. And then we have the 172.16.34.34, which is the eBGP session to ISP 3B. So note that there is no, at this time, IBGP session between routers 1 and 4 at the moment. And once again, we are learning prefixes. So now we're going to go back to router 1 just to see what router 1 is advertising, which prefixes is router 1 advertising. So I'm going to go back up to router 1, and we're going to type the command show IP BGP neighbors, and I'm going to like to use the tab key, so I'm going to hit the tab key here to fill in the word neighbors. And then we're going to put in the specific neighbor, so we're going to put in 10.0.0.17, and we're going to say advertised dash routes. And again, I use the tab key. So when we press enter, we can see the table here. So router 1 is advertising, these prefixes. So locally originated prefix, you see the 10.0.0.0/28. We also see all the prefixes that are originating on ISP 1's router. So those are the 10.0.1.0/24 subnets in Autonomous System 100. And we can see that down there in the table. Let's do the same thing on router 3. So if we go to router 3, again, we're going to do show IP BGP. And we can see the content in this case. So we're seeing the prefixes originating on the ISP1 router, which are the 10.0.1.0/24 prefixes. Notice we see a bunch of those. They are received on router 3. And on router 3, we also want to verify which routes are advertised to router 4. So to see that, we're going to go ahead and say, OK, show IP BGP neighbors. And we're going to put in the address, 10.0.0.49, and then advertised routes. I hit the tab key again. And now when we look, we only see only locally originated prefix in this case, which is the 10.0.0.16/28 is advertised to the router 4 router. So there is what we call a split horizon rule that's preventing router 3 from passing the received updates from router 1 over to router 4. So let's go on router 4 to verify the content of that table. So if we go to router 4, we're just going to go ahead and do a show IP BGP. And if you look closely in the table, you should see that the prefixes originating on the ISP1 router, which again are the 10.0.1.0/24 prefixes, are not being received on router 4. So we don't see those in this table there. So now we're going to look on router ISP3B to verify the content in its table. So let me bring that one up. And we're going to type show IP BGP. And you should see, because of the IBGP split horizon rule, that prefixes originating on ISP1 router, which are the 10.0.1.0/24, are not being received on ISP3B's router. So what we're going to do is we're going to configure a BGP cluster ID of 1, which is just matching our autonomous system number on router 3. Then we're going to configure the router 3 router to be a route reflector for the client routers R1 and R4. So let's look at how to create the route reflector. So again, we're going to go to router 3. And we need to go into BGP, so we're going to go to our global config first. So I abbreviated the command configure space terminal by just typing config space T. And then we're going to go into BGP, so router BGP1. And we're going to go ahead and say BGP cluster ID 1. And again, we're just using our autonomous system number as the cluster ID. And notice we see, some adjacency changes. And if you wait a little bit, you can see it coming back online once we define the cluster ID. And then we're going to say, okay, neighbor, and then 10.0.0.1. And we're going to say route reflector client, and I hit the tab key on that one for the tab completion. And we're going to say neighbor, and notice we get an adjacency change, which is a good message. We want to see that. We want to see it doing a configuration change. We want to see it communicating with the neighbor. We see the route reflector client config change on the far right, and we see the neighbor has come back online. So we're going to go ahead and put in the other neighbor here. So 10.0.0.49. And again, route reflector. And I'm hitting the tab key, client. And again, we see that it went down. The route reflector client config change again. We see the neighbor address. And again, route reflector client config change. And again, the neighbor is back online. Now, just so you know, the cluster ID can be from the number 1 all the way up to something like 4 billion. The cluster ID can also be in a 32-bit dotted decimal format as well. In this case, we just use the autonomous system number to make it easy. That you don't have to match that, but that is something that some folks like to do. So notice that only the route reflector requires the additional configuration. So again, the command is entered for every router that will receive the reflected routes from router 3. In our case, it's router 1 and router 4. So if we go back to the diagram again, right, router 1 is going to send, router 3 is where we're configuring it to talk to router 1, and router 3 is where we're configuring it to talk to router 4, just so we understand where this is going to be applied. Now we're going to look at monitoring route reflectors, right? So we're going to issue some commands to now go back and see, the things that have potentially changed. So let's head over to, in this case, we're going to go over to router 3. And we're going to go ahead and do the do command, so I can issue a show command right from here. So we're going to do show IP BGP neighbors. And I'm going to put in the specific neighbor, 10.0.0.1. And we're going to press enter. And let me scroll up a little bit. So again, we can see the neighbor here. We typed in 10.0.0.1. The remote autonomous system is 1. Internal link means that it's an IBGP neighbor. okay, in this case. And we do see all the statistics, all the different messages, that what's been sent, what's been received, what's been sent, what's been received. So you can see those details. And just continuing that down. So what we want to do on router 3 is we want to, see, which is now acting as a route reflector. We want to verify that router 1 is configured as a route reflector client. So that's what we're looking for. So again, I'm just scrolling up so you can see the config. And right here, you can see that it is a route reflector client. And that's what we're looking for in this case. So on router 3, which is acting as the route reflector, we want to verify the additional information in the BGP table for the prefix 10.0.1.0/28, which is originated on the ISP1 router. We want to make sure that the route was received from the route reflector client. So now we're going to head over to typing this command. We hit Control-Z just to go back to privileged mode. Show IP BGP, and we're going to do 10.0.1.0/28. And notice we have an entry. Notice the parentheses where it says received from a route reflector client. And that's what we're supposed to be seeing. So we see the BGP routing table for the 10.0.1.0/28. It gives us a version number. We see we advertise to the update groups. And down here we can see the IPs and the stuff as far as the BGP attributes. So now let's check router 4. Okay, so if we go to router 4, we're going to do show IP BGP 10.0.10/28. And again, we do see it here as well. So on router 4, which is acting as a route reflector client, we can verify the additional information in the BGP table for that prefix, again, 10.0.10/28, which, if you remember, originated on the ISP1 router, and we want to make sure that that route was reflected from the route reflector R3 over here to router 4. And here we can see that it has there. We see the entry. And you should see that the originator of the reflected route was the route reflector client R1. And if you look at the 10.0.0.1 and also notice the BGP cluster ID, in this case, is 1. So again, we can see the originator, and right there at the very bottom, the cluster ID. So now we're going to go to router 3 to verify which routes are advertised to router 4. So let's go over to router 3. And we're going to do the command show IP BGP neighbors. And we're going to put in the address. So 10.0.049. And again, advertised routes. And I hit the tab key on that one. Now we should see the prefixes that originated on, in this case, ISP1, Internet Service Provider 1, and we should see the 10.0.1.0/24 subnets. So the those routes are being advertised from the R3 router to the IBGP neighbor R4, because remember, R3 is acting as the route reflector. And we do see those subnets in there. So we do see the prefix originating on the ISP1 router, which again are the 10.0.10/24 prefixes, are received on router 4 because they were reflected from the route reflector, router 3. So now we're going to head over to the big finale. Let's go over to ISP3B and make sure that those prefixes are now over there. So if we go over to ISP3B and we do the command show IP BGP, we should now see those prefixes in there. And sure enough, there's a bunch of them down at the bottom. So we see plenty of the 10.0.10/24 prefixes. And that is our big finale, folks, on how to create a BGP route reflector. And I hope you enjoyed this session. And I'll catch you guys next time.